Hello everyone, welcome to my channel. So in the last couple of lecture, I have already discussed about some important application part of lithium aluminum hydride. As you know, lithium aluminum hydride, it can act as a strong reducing agent. So today's lecture, I am going to tell you couple of examples where lithium aluminum hydride, it can selectively reduce both this double bond as well as some active functional group like aldehyde or acid, etc., etc. So in the first example of today's video, you can see that if you take this kind of alpha beta unsaturated aldehyde, now if you try to perform the reaction in presence of lithium aluminum hydride with excess amount at a certain temperature, it will gives this saturated alcohol product. Now if you look at the substrate where this lithium aluminum hydride, it will selectively reduce both this aldehyde group along with this double bond. So as a result, it provides this saturated alcohol product. You can see that aldehyde group converted into alcohol group, and this double bonded also reduced, and ultimately it provides this product. Now if you do some variation, let's say if you take a certain amount of or measurable amount of lithium aluminum hydride, and if you perform the reaction at low temperature near about minus 10 degree centigrade temperature, then it provides, you can see selectively this lithium aluminum hydride, it reduce more active aldehyde group. So as a result, it provides this unsaturated alcohol product. So what would be the mechanism? You can see, so initially if you take this particular unsaturated alpha beta unsaturated aldehyde compound, initially this lithium aluminum hydride, that hydride which is basically coming from the anionic part of lithium aluminum hydride, it will attack over there and it will form this kind of intermediate, and after that, so there is a another hydride, it will attack over this in this particular double bond, and there is a simultaneous, you can see there is a formation of 5-membered ring with this aluminium. Now further, another equivalent of this alpha beta unsaturated aldehyde compound, it will further take part in this following reaction, and followed by the acidic workup, it will gives the desired product. Okay, now coming to the next example. So if you take this alpha beta unsaturated acid, you can see alpha beta unsaturated acid. Now if you try to perform the reaction in presence of lithium aluminum hydride and diethyl ether solvent medium, now you can see it will provide a 1,1-diphenyl cyclopropane compound. You can see. On the other hand, if you take this the dimethyl base alpha beta unsaturated acid, and if you perform the reaction by taking lithium aluminum hydride and diethyl ether solvent medium, then it will selectively reduce this acid group, and as a result it provides this kind of alcohol product. And here this lithium aluminum hydride also reduce both this double bond along with this acid group. Now what would be the mechanism of the first reaction? So the mechanism suggests that, you can see this lithium aluminum hydride, initially it will attack over there in this acidic carbonyl group. Now further there is a cyclization takes place. Now after cyclization, you can see there is a formation of a carboanion species over here, carboanion species. Now as a result, that carboanion species, that negative charge, it can act as a good nucleophile and it will attack over there, and this particular group goes out from the reaction mixture, and as a whole it will provide this cyclopropane compound. You can see 1,1 diphenyl cyclopropane compound. But here you can see, if you take this dimethyl base alpha beta unsaturated acid, only it will give this kind of alcohol product. So what would be the reason? You can see in this mechanism there is a formation of carbocation. That carbocation is stabilized by this 2-phenyl group. On the other hand, instead of this 2-phenyl group, if methyl group is present like this carbanion, it may not be stable. So that is why we are getting this kind of product in case of this substrate. On the other hand, we are getting this kind of cyclic or cyclopropane product by taking this substrate. Okay. Next, coming to the another example over here, you can see this particular substrate, you can see it contains this triple bond, 2 triple bonds, 1 double bonds along with this carbonyl unit. You can see now if you try to perform the reaction by taking lithium aluminum hydride at tetrahydrofuran solvent medium at low temperature, now selectively this particular triple bond, it will selectively reduce over here along with this ketone group, it will also reduce, and as a result it gives this kind of alcohol product. Further, if you take this bicyclic, you can see diene product, diene substrate. So ultimately if you perform the reaction, it will never give any kind of product. Okay, thank you very much.